So hi everyone, my name is Jean-Philippe and I'm working at Datadog. I'm also an OpenJDK committer for JDK Mission Control and Java Champion. But today we will discuss production profiling. I think everybody one day has used a profiler to find performance issues. And JFR, JDK Flight Recorder, was designed for production time. And we are using it massively at Datadog. So this talk is an introduction to JDK Flight Recorder, JFR, and JDK Mission Control, JMC. I would like to start by a quote from Tony Printezis, this JVM engineer at Twitter. During his presentation at Devox 2015, he said that the big challenge is no longer really performance, and the big challenge is profiling, especially profiling in production. So what would expect from a production profiler? So we expect a minimal observer effect, which means a low overhead, barely measurable, not affecting the behavior of the application, and not reverting any optimization done by the JIT. It should also be safe to use in production. It means well tested and also widely used. So the JDK Flight Recorder is like the data flight recorder you would find in a commercial jet. But instead of recording what's happening in an aircraft, it will record what is going on in the JVM and the application running on the JVM. The flight recorder, even when recording quite a lot of different kinds of information, has very low overhead. It's typically less than 1%, thanks to its high-performance record engine. So JFR will record JVM information. You can add a custom events to record your own information with a Java API. It helps you to solve a wide range of problems. It's not just another CPU profiler. While beginning its life as a commercial product, it has been open sourced in OpenJDK 11, and later backported to OpenJDK 8 since update 262 to 72. The 262 is for most vendor, and for Docker images you want to use, you should use the 272 with the upstream build. Okay, so how JFR helps you to resolve problems faster in production? Imagine you have an issue in production, but only happens in production and cannot reproduce in test environments. So with JFR data, you can always be recorded and you can process them post-mortem to find the cause of your issue. Also, the profile files can be shared or centralized to your observability system to be processed. The JFR recording has very low observable effect, as it does not undo any optimization like the scalarization, as known as escape analysis, and stack traces are collected without safe points. It's just like the async profiler, if you know about it. So JFR is bundled with a comprehensive toolchain. You can control flight recorder using command line parameter, the -XX flight recorder options. You can use a Java API, JMX API with the, for example, Visual VM or JMC. JCMD is a command line tool provided by the JDK, and finally, the JDK Mission Control. So you can add a custom data event through a Java API using JMC. Sorry. So you can add so the custom data event through Java API using JMC agent or by third-party integration like OpenTracing, Brave, etc. To consume the data recorded, you can use the JMC app, but also the JMC core libraries or JFR command line tool provided into the JDK. The data collected by JFR are recorded as events. Those events are data points in time and have typed and self-describing attributes. So you can record specific types like size in bytes or time in milliseconds. So the JFR is already recording different kind of data for CPU profiling, allocation profiling, thread latency profiling, GC compiler, GC, compiler, memory leak provider, file, and socket IOs, and much more. The size is typically 2 megs per minute. That's about 100,000 events for that kind of recording. Internally, JFR has a thread local buffer into which most events are recorded. Once full, they get copied into a circular arrangement of global buffers. And depending on the configuration, this buffer can simply keep overwriting them, and we can decide to dump them at some other time, or emitting them to disk for further analysis on your local machine or in your observability system. You can add your own JFR event. So what for? For example, in the context of distributed tracing, you can record your own event, the trace span ID, which will be recorded with the same timestamps than the others event, because piggybacked to the whole JFR infrastructure, which can help you correlate long-lasting span to actual issues in a JVM or application. The event can be consumed like any other events. So you can also benefit from JFR infrastructure for cheap timestamping, collecting stack traces without save points, and a compact representation. Here, a very basic example of a custom event with only a string for storage. You create the event, store the message, and then you can commit. So regarding performance, you benefit from the JIT optimization. So if the event is disabled, in this case, the event is optimized away with scalarization plus the commit, the inlining of the commit method, and because it's dead code elimination, it will be completely removed in that case. A more complex example where you can annotate fields, attributes with types of data. They store size in bytes, address in hexa, or timestamp in milliseconds, which help consumer to display correct information. So you can think about the GMC, for example. You can control Flight Recorder by different means. Through JMC via JMX connection, local or remote, locally with command line and GCMD, through JVM command line flags, and programmatically with either JMX API or Java API. JFR is able to use template files or configuring events. For configuring events, those templates contain information about what and how to record events. So what event types to enable, what threshold you use for events with duration, what periodicity to sample requestable events, and inside the JDK packaging, 2 JFR template files are provided. The default, which has less than 1% overhead, and the profile, which with more information and less than 2% overhead. So those templates are located in deep JFR folder into the JDK, but those templates can also be edited via the Mission Control. Once you have recordings, how to process and consume them. You can use a command line tool provided by the JDK itself, JFR, to look at the recordings. JDK is also shipped with a parser to load recordings, but it only supports the current version of the JDK and perform only external iterations, events to events, and nothing to attribute levels. JMC is shipped with its own JFR parser, which supports all versions of JFR since the JDK 7, when Mission Control was Flight Recorder was introduced into the JDK. This library compiles and runs with JDK 8 and above. It also includes analysis rules, which is a set of heuristics to help you diagnose issues inside the recording. And you can perform a declarative and internal iteration of the recording and aggregate across attributes of events. Those artifacts are available on Maven Central now. And of course, the JDK Mission Control application itself will ease the browsing of the recording. At Datadog, we process recordings in our backend with the core parser and display result in our web UI. So this is an example that we can have on our own. So regarding profilers, you should always be aware that of the biases that have those profilers. Some will change the runtime behavior and do some optimization, like the escape analysis, and some are safe point biased. So you can have more information about this in the Nitsan talk. Profilers are lying hobbits, and we had them. That's a recommended video and presentation to look at if you want more detail about it. Each profiler has been designed with some trade-off. For JDK Flight Recorder, the execution samples are chosen to be very low impact and constant overhead. So we have maximum 5 threads per sample cycle and does not include native thread samples for that. Allocation profiling is sampling from the TLAB retirement. So this is an estimation, but a good one over time. And JFR collects the contextual information, like, for example, logs. For the logs, you have the thread monitor class, which thread is holding the log, and its monitor address. But there is always a price, and here this is the threshold. So basically, it's 10 or 20 milliseconds, and that's good for outliers, but maybe overflowed by some with just above the threshold or missing a lot of them just below this threshold. So let's take a look into the JFR demo. So I have here a Spring Pet Clinic application. And I would like to start this application with the start flight recording. So I'm using this option recording, and I have some option to put, like the file name I want to dump my JFR recording. I want to dump this recording on exit of my application, and I'm using the settings, so the template file profile, and then I can jar my application jar. Yes. So I'm starting so it start the JFR. There is a hint about starting the JFR. So, and after I've started my application and background, I can use the JCMD to look at the PID of my application, this one, and then I can have a list of commands that I can apply. There is a couple of commands from JFR to have a look into the status of the JFR for this application. So I can check where I have one recording that is started. I can start a new recording with start. It will be named name 2 here. So we have 2 now recording started, name 1 and name equals 2. And I can use JFR.dump to dump the one that I've started from the command line, and using a file name, for example, temporary2.jfr. So it will write this recording into the disk, this location. There is only one megabyte inside it. And then I can stop the recording from this name 2. So it stopped the recording 2. And if I can check again, I have still the recording 1 that is started with the application. Then I can use the JFR command to look into the recording I have done. I can also dump the main one by stopping the application. Okay, so I can look at the summary of my Pet Clinic recording. So let's have a list. So here we have the content inside the recording, number of chunks, the duration, the version it used, and I have an histogram of all the event types and the number of events for this type and the size of on disk of the sum of those events on disk. And then we can have one type, and we can look inside the event by using the subcommand print, selecting the events thread park on my recording, and we print all my events with all information, the park class, the thread name, and the address of the monitor. And we have also a stack trace where those thread park were taking place. You can look at the ellipses on the stack trace. If you want the full stack trace, by default it's only the 5 top frames. You can add the stack depth option to have like 128 to have the full stack traces. So now we have the full stack traces here. You can also export this into a JSON format if you want to process it afterward. So that may be easier to process than parsing the output with grep. Okay, let's continue on our slides with JDK Mission Control now. So JDK Mission Control is a tool suite that encompasses JDK Flight Recorder for creating recording and analyzing them. We have also a JMX console for real-time monitoring, like the visual VM. And we have additional plugins like JOverflow that is now integrated by default, and extra JFR tooling like event metadata, G1 visualization, etc. And also a plugin to create a GMC plugin. GMC is actually an open source project under OpenJDK. The main contributors are Oracle, Red Hat, Datadog, and some external contributors. Binaries are redistributed by Oracle, Azure, Bellsoft, OpenJDK previously, Adaptium now, and also an Eclipse plugin. So you can get JFR recordings from different sources. You can have from local JVM, and local JVM are automatically discovered by GMC with the JFR already enabled or not, from files brought by other means or from remote JVMs. From GMC, you can control the creation of recording through a wizard, and then browsing those records with a rules overview with the result of this analysis, pre-built pages like method profiling, logs, memory, etc. Event browser, which gives the full content, even the custom ones. And finally, you can add some custom pages for existing events for your custom ones. So let's have a demo on GMC. So we have already opened this recording, and first you land on the automated analysis results that give you some hints on the category you should focus on. So for example, in this recording, we have some application halts inside, like 18% of the time, execution time is spent into the thread are into a save point, so maybe that's the GC. And if you look at the garbage collection, they say like there is a lot of pauses due to GC at 18%, so you should focus on this kind of thing. There is also some socket IO that are very long, but maybe we should take a look. So that's the first entry point of your recording with the analysis of the events and those heuristics. You can try to work on the issue with that. Then you can take a look at other pages, like for example the memory one. Open this one. Yeah. With Zoom, it's a little difficult. Yeah. So here we have the histogram of the classes that is that are allocated a lot. So, for example, we have the long boxing class that are very allocated a lot, so the 10 gigabytes, 14% of the allocation, and you have the stack traces through a flame view here to see where those allocation happened. You can also have the stack trace view for this. That's the same representation than flame view, but as a tree here for the stack traces. You can look at the method profiling to see what the CPU is spending a lot. Again, you have the stack traces associated with the predecessor and successor for this method, for each method. And you can have some information about the garbage collection with all the pauses and some phase inside the pause also that are breakdown here. For example, we have 4 milliseconds inside those 600 milliseconds just for class unloading. And you can have also the event browser, where you can have all the events inside the recording by category. So the JDK virtual machine, and you also have, for example, in this one, we have spatial and custom events. And for example, here, and you have the full event here with all the information, all the attributes, even though those events are not part of the JDK, because that's the one that we have added into our application. But this way, you can have all the information and all the custom events directly here to be browsed. Okay, let's go back to our presentation if you want to go further. So here is an example of the usage of the JMC core library for processing and aggregating events. So I will do a demo on that tomorrow. So you can process and automate the recording like this. You have also a small example of actually create a report of the whole analysis in a HTML format. So the one that you see in JMC, you can also externalize this to integrate with your observability system. So you can create the HTML report and show it in your intranet or something. So let's have a demo of the JMC core library. So JSON. Okay. So that's a demo that you can find also on GitHub. So it's a JSON integration with all the imports to be able to play with the core library directly. I'll open also the flame graph one. I did a new one. So let's take a look at how we can use this event, this core library to load a JFR file. So you can load a toolkit and load events and methods with a new file that I have locally. So let me see JFR. So I'm loading this recording, and now I would like to filter the events for the one that have a monitor enter. So that's entering into a monitor lock. So I'm applying filter on the type not type ID of monitor enter events. So I filter on monitor enter, and now I would like to perform an average of the duration of those events. So I'm get aggregate, and I'm using the aggregator average on the JFR attributes duration. So I'm getting this average, and this average I want to display by default. So my average waiting time on those synchronized blocks is 3.5 seconds. That's a lot. So maybe I should take a look on this. We can also filter with another JFR on GC. So I will take another load events, another recording. This one is TTSP JFR. Okay, loading those events. And now I would like to filter on my GC events. TTSP events. Apply item filters from type JDK, type IDs, garbage collection. Perfect. And now I would like to know from those GC events the maximum pause time of those GC. So equals GC events, but get aggregate. I'm using the aggregator that is max. And on JFR attributes duration. So what is the max? And the max I want to display using the default one to be human readable. And the max GC is 280 milliseconds. So that's not that bad. So that's great. And now I would like to show you another another recording, and I would like to generate a flame graph from the stack traces that are collected by those events. So let's load this one file again from disk, and this one is .jfr. Should be okay. That's great. And now I will filter the execution sample events. Some prof events, apply item filters from type JDK type. So execution sample. So execution sample are the profiling, the CPU profiling itself. So when we take all the stack traces from and we get the methods. So I'm filter on the execution sample, and then I've imported a function that I've written before, the export to collapsed, that helped me to export the stack traces that are recorded by JFR to the format of the input format of the flame graph. That's a collapse version. So those, and I'm storing this into a file, and the prof analyzer and txt. So I've exported this. Let's go to this prof analyzer txt. So we can look at those exported format. So you can see that all the stack traces are separated by a semicolon, and I have the number of stack traces at the end. And then I can use the flame graph from Brendan Gregg, the flame graph script with the prof analyzer here, and export it to prof analyzer SVG. Okay, and let's open it into a browser. Let me show you on my screen. Okay, and you can see that that's a flame graph from the JFR recording, and that's a fully flame graph, fully functional. like this. So you can export your event and even your custom one in FlameGraph if you are ready to do this. We have time to have also another demo, another also based importing again FlameGraph, and let's have also the FlameGraph for the monitor enter events. So again, loading again another the same one, same custom one, new file, data proof analyzer, JFR. I will also filter all the events filters type JDK type IDs and monitor enter. So I would like to have the stack trace for the synchronized block. And I can export to collapse JDK example to a new file. And this one will be monitors.txt exported. Okay, let's see those monitors. Okay, sounds good. And now I will export to FlameGraph. So the classic script, and this is monitors. Yeah, and export that to SVG. Okay, let's open it now. Monitors SVG, that's the one I want to take a look. And okay, that's the FlameGraph of monitor. So we have fewer monitors that are have contention. One here, clear interrupt, one here to get the name service address resolution. And this one also, that's the same method with a different stack trace. Okay, let's go back to my presentation. We have also the GMC agent. This is an incubated project with GMC agent which allow you to insert on the fly some custom events everywhere in your application. This way you don't need to recompile or insert an event yourself. So you can, the GMC agent will use the instrumentation to insert those events for you. So you have to declare through this configuration which event, so a custom event, my event, and also which class and method you want to instrument, and they will insert this this event on the fly. And then you can dump the recording and look at those events yourself. So in summary, you have a lot of resources you have the repo of GMC under the OpenJDK project. You have the mailing list to have information about it and to ask questions. We have also a Slack that is open to everybody. So if you have questions about GMC, if you want to improve things, you can connect to this Slack and ask questions. You can download GMC with the distribution of your choice. That's Oracle or Azure, Bellsoft or Adaptium. You have a GMC tutorial if you're not familiar with GMC yet at this address. It's the Marcus Hirt GitHub that is the lead of GMC. And with that, we can go back to the studio if you have a question, and I can answer it.